Alright, in this section we are going to talk about the composition and how one makes sense of all the created image and audio resources. This is done by the means of a composition playlist. A composition playlist is an XML document that consists of metadata pertaining to segments which are comprised of ordered sequences consisting of image, audio, and time text track file resources. It is very commonly referred to by its acronym CPL. When ordered together, these segments compose a motion picture composition of varying composition kind. The CPL controls the order and timing of playout of said segments. As such, the interoperable master format is known as a composition. When packaged for business-to-business exchange, it is referred to as an IMP, interoperable master package. So how does this look visually? Let's take a look. As mentioned, a CPL is an XML document. XML is markup language, and markup language is comprised of a series of document elements. Therefore, a composition playlist is best understood when broken down into components. At the very top level of the document, we have the prologue. The prologue contains static information which describes the document type, its encoding, who and what created it, the time it was created, and lists its ID. This then gives way to the header information within the document, which contains information such as who owns the content of the composition, the title of the works, the composition kind, and any annotative descriptions of the composition. Next, we have the version identifier. Although one could argue that such an element is part of the header, I have it separate as the field has the means to carry an identifier value, which for example can act as a dictionary reference to an external database if a lookup request was called for. Essence description is next, and it does exactly just that. It is an element tree within the CPL that contains the descriptive metadata of each essence type from its corresponding resource MXF track file in an XML form. Here, you will find all the attributes, say for image, its transfer characteristic, coding equations, color primaries, etc. The timecode element dictates the timecode type to be used as a representative of the composition. You also have the total running time at this section too, which indicates the approximate duration of the composition when the CPL was created. Locale data highlights the intended audience of the composition, such as what region it is targeting, the maturity rating of the content, and its language. The application info contains a reference to the application type the composition is constrained to adhere to. And the final listing is the segment list. The segment list lists the order in which the virtual track sequences shall be presented to a system for playout. Within each segment, you have a sequence list for each underlying essence type, image, audio, and data, each of which are comprised of the resources we discussed previously, here within their own resource list. It is important to note that a single segment can only contain a single virtual track of a specific essence kind. However, each sequence can contain multiple resources. Finally, with all elements listed, you can see the constrained relationship the application dictates, which essentially enforces such constraint by verifying the descriptive metadata of the essence in the CPL, which in turn was extrapolated from the corresponding MXF resources. If any conflict should arise, the composition will be deemed invalid. Make sense? Probably not, and that's okay. Don't worry about it, because we're going to break it down even further. This time, let's present a CPL in a layered manner, such as how one would see all AV assets in a non-linear editor, an environment we are all very accustomed to. Okay, so the structure you are now seeing is pretty much how any playback system will present you a CPL after ingesting it for editorial or any other work. In this instance, we have a single segment composition comprised of image, audio, and time text data with an overlaying marker track. But what about our resources? Let's take a closer look at our sequences in this segment and go deeper. Then, we will work our way back up to the top level. Alright, so our resources are back in view. Let's focus on the image sequence. As you can see, this sequence is comprised of 3 image MXF resources. In this instance, this composition is a version composition. Looking at the resources in their complete form, we can see that certain sections are omitted, such as leaders, slates, and tail cards, with only specific temporal regions of interest being displayed. This version, for argument's sake, is a French version, which required the main titles to be replaced with a localized instance along with the end credits. This is accomplished by leveraging the power of MXF and IMF through a componentized workflow. Upon creation of the CPL, Editorially, we tell the system to 1. Play the French main title for a specific duration period. 2. Via an offset mechanism, an entry point value. It then starts the main program at a designated frame, plays for another specific number of frames, and finally, 3. Reference the end credits resource and play for n number of frames from this resource's entry point. All these resources comprise the image virtual track resource list. Motioning our way back to our sequence list within our segment, the same methodology we just explored with the image track file is also applicable to both audio and data too. Now, when it comes to working with segments, there are a few rules that need to be adhered to. In a single CPL, the characteristic attributes of each resource within a sequence of a virtual track must be the same, in that all characteristics of an essence type need to be homogeneous across all resources within that specific sequence, with each sequence in turn requiring to be homogeneous across all segments. Also, no gaps between resources within a sequence, and all virtual track sequences must be the same duration. Alright, coming back to our top level view, let's focus a little more on a piece I've just glossed over until now, and that is timecode in IMF. A few key things, and probably one of the difficult things for many who are new to IMF to wrap their head around. IMF does not rely on timecode for playback. Instead, it incorporates a composition timecode element which associates a specific timecode type with the CPL timeline. This timecode type is a canonical synthetic timecode, which is a timecode created based on the synchronized synthesis of the metadata information contained within the composition. If the use of a timecode is of interest to you, the IMF community through the IMF user group have published a best practices on the utilization of timecode in IMF. Be sure to check it out.